everybody. So, well, I should say everybody. It's not too many people joining us right now. But that's okay. So we are doing exponential models based on percent growth. Your homework tonight is going to be in Khan Academy. Move my microphone a little bit. There we go. All right. So your homework tonight's in Khan Academy. There's 2 practices in there. Just a reminder to be able to get exceeds or above expectations, you would have to get 100% mastery. To get meets expectations, you need to get at least a 75% or higher on those. And to get below expectations, it would be anything that's lower than a 75 but not a 0. And if you get 0%, that's considered incomplete. If you look at in the files tab, you'll see like an expectations doc that I posted last week. Check that out because all the details are in there. All right, so let us begin. Oop, now my microphone's like totally in my way. Okay, so we're going to be putting together what we did last week into context. So there are many examples of exponential growth in the real world. Really, exponential growth right now with the COVID-19, though we're on the downward slope, so it's going to be start to looking quadratic. Lesson for another day. Let's start with an example. A population of fruit flies is growing at a constant rate of 6% per hour. Super important. And it's growing. Okay. The population starts when time is equal to 0 with 28 flies. So part A says use what we learned in the last lesson. Determine the population after each of the following amounts of time. Show the calculation you use as repeated multiplication. So, all right, if we're doing growth, remember, oops, didn't want to be on the highlighter tool. We always start with 100% because that's our original population. And then since it's growth, we're going to be combining that with 6% to get a value of 106%. Which, if I wanted to physically calculate after the first hour, I would move that decimal over twice to get 1.06. Now, the other way that you might see in your homework tonight is sometimes, instead of going from percent to decimal, sometimes you can just go to decimal and then combine them. So what I mean by that is if I wanted to turn 100% into a decimal, I would move that place over twice, right? So it's really like I'm saying 1 plus the 0.06, because if I was to move that decimal over twice, to also get 1.06. So in your homework, you might see the problems go directly to what I wrote in blue, but just know that those 2 things mean the exact same thing. All right, so what we're going to do is we're going to start with that initial population of 28, and then we're going to increase it, so we're going to multiply by that 1.06. Remember, we're doing, let me write that a little nicer. We're doing 106% of 28, so 1.06 times the 28, or 28 times 1.06. Technically, with multiplication, the order doesn't matter. So if we're talking about population, I want to round to the nearest whole. So when I type this in my calculator, I get 29.68 and some change. So it's really about 30 flies, 30 fruit flies. So if I wanted to do for 2 hours, I would just repeat this. It's still 6% growth. That was going to hiccup soon. So I would do 30 times 1.06. Oops, I need my calculator. I forgot to compute this one. My bad. Excuse me. Oops, not 31. Silly me. And we would get about 31.8, which is about 32. But there's also another way we could look at this. So what I did was I took my previous answer and I multiplied it by another 1.06, right? So let's actually do that. So I'm really going to be doing 28 times 1.06 times another 1.06. And remember, when you multiply something with the same base, you increase the exponent. So if I was to ask you 3 times 3, you could say that's 3 squared. So really, what we can do is rewrite this as 28 times 1.06 squared. 1.06 squared. And remember, we're talking about flies, so I want to round to the nearest whole. We get 31.4608. So remember, I used the rounded answer from the previous one above, so that's why it's slightly off. So we're going to say it's about 31 flies. About. And then if I were to do this for 3 hours, I would really do 28 times a 1.06 times a 1.06 times another 1.06. Well, it's really annoying to write over and over again. So if I asked you for like the 32nd hour, like, are you going to write this 32 times? No. So we really want to write this as 28 times 1.06 cubed. And we type that in. We get 33.348. So we're going to say about 33 flies. So based on this, could we think of a formula to generalize it? If I want to find the 88th hour or the 90th hour, what do you notice about those exponents? Well, the exponent is the amount of time that passed. Technically, we were looking at the first one. There was an exponent of a 1 here. We just didn't write it because it seems silly. For hour 2, it was squared. And for hour 3, we had it cubed. So if I want to generalize this, and I use a different color, as a formula, it says, let's see, it gives us some specific directions. Based on A, find a formula that multiplies population T, models the population P as the function of time. So we could say P of T equals that 28 times 1.06 raised to the amount of time that passed. On your homework tonight, one of them, you'll be expected to do this. So put a little star or highlight this, because you're going to get some questions like this one in your homework tonight. So refer back to that. So moving forward, if I wanted to find for P of 24, that means 24 hours, we would say 28 times 1.06 raised to the 24th. And again, we're going to round to the nearest whole because we're talking about population. So we get 113.37. So we're going to say about 113 fruit flies. Okay. So D says, what does your calculation you made in part C represent about the fly population? State the range of the population over the domain. So our answer in part C means at the end of one day, which one day is just 24 hours, there will be about 113 fruit flies. Now, the domain represents your x, which in this case represents time, because time is always your independent variable. So between 0 hours and 24 hours, we got to think about how many fruit flies. What was the population? So here in this case, the range is representing population. So at 0 time, how many fruit flies did we start with? Well, if we look up, we started with 28 fruit flies. I should label this as the range. And then my pen froze. Yay. There we go. I'll put P of T in there. And then we ended with 113. So at 0 time, we're matching that up with 28 fruit flies. And at 24 hours, we're matching that up with 113 fruit flies. If we were to graph this function, which you can just sketch it in your notes, doesn't have to be exact. We started at 28. Remember, it's 0 time. This is 0 hours. Oops, I wrote it, but then it disappeared. Weird. Da-da-da. So say this is 0 hours. We were at 28. And then at 24 hours, we were at 113. So we can see we get this nice curve going up. I'm going to make that a little bit more curve-like. Right now it's looking a little linear. There we go. And I guess I should stop at the point. Oh my goodness, my drawing is so bad today. Whatever. It's a curve, right? All right, very good. So let's try another one. If a savings bank account is modeled by this equation, which of the following is true? So let's take a look at this. If we modeled this based on what we had above, so I'm going to write the one we had above. So from up there was 28 times 1.06 to the t. That's what we were working with. Remember, 28 was the number of flies we started with. So if we're talking about a bank account, that means that this amount of 250 must be the money we started with, or the money that they initially deposited in the bank. Any number that you get in those parentheses that's bigger than 1 is representing growth. Remember, because you always start with 100% or the number 1, and then if you're adding, that's growth. So if this was something that was less than 1, like 95 or 88, something like that, then it would be decay. But since it's growth, this is really 1 plus 0.045. So we know it's growth because I'm just breaking that number up. And remember, 1 really represents 100%, which is your original. Plus, if I wanted to go from a decimal to a percent, I'm going to move this over twice. So we really have 4.5%. So this 4.5% is our growth rate. Okay, so I do want to make sure you get this written down in case you have a question where it wants you to interpret an equation. So make sure you get all that goodies down. So based on that, let's see which of these works out. Let's see. So they all okay, so we know initial deposited was $250, so that means it can't be 2 and it can't be 4, so that's nice. And we moved our decimal over twice to get 4.5%, so therefore it's got to be choice 3. Okay, so knowing how to make that, break it apart. So now that we've done a growth model, let's show a decay model. So something that is decreasing. So as water drains out of a pool, the depth of water decreases at a constant percent of 20%. Whoa. That's good though. That means if you're draining your pool, you don't want it to move too slow. So 20% per hour. The depth of the water begins at 12 feet. Ooh, we got a deep pool there. Nice. All right. So similar to how we started the first one, we want to know how much is left after 1 hour. So recall, we're always going to start with 100%. And since we're decreasing, we're going to take off that 20%. So we know that we're left with 80%. Remember, you could also see it written as 1 minus 0.20 to be left with 0.8. Or 0.80. Because remember, the one we found, we have to move that decimal over twice to get what's going to be left in the parentheses. So if we want to find 80% of 12 feet, we're really just going to take that 12 and multiply it by the 0.8 or the 0.80. If you want to put, I'll put the 80 in there, make you feel a little better. And then see what we get. Now, because this is depth, we're not going to just round to the nearest whole because you can have, fractions, decimal answers for depth. So in this case, we get 9.6 feet is left, which makes sense. We want our answer to be smaller because we're draining it, right? So next we have after 2 hours. So that would be, I have that 12. And I'd have to multiply it by that original 0.80, but then I'm going to do it again because It said it was being constant at that rate. So remember, the other way to write this is 12 times 0.80 squared, which is going to give us 7.68 feet. And then if I wanted to do this for after 3 hours, I would really do 12 times 0.80 times 0.80, and then I got to increase it by another, or decrease it rather, by another 0.80, which is super annoying to write. So we're just going to write it as 12 times 0.80 cubed, and that's going to give us 6.144 feet. So just like before, the exponent is representing the amount of time. And that first one we didn't write it, but technically there's a little 1 there. When it was 2 hours, we saw that the exponent was 2. And when it was 3 hours, we saw that the exponent was 3. So if I wanted to generalize this as a formula, I could do d of t equals that original times 0.80 raised to the t. And again, you're going to want to make sure you have this written down because you will be expected to write some equations like that in Khan Academy. That's due on Thursday. And just like before, we see that the 12 is our initial value. And then this is our, I guess you could call it the growth rate, even though it's decreasing. So by growth, I mean it's like going down, right? So if we were going to graph this, which you can do on your graphing calculator, we would start up here at 12. Remember, this is like 0 hours. And then let's say, oh, excuse me. And then as it goes, we could see that the number was getting smaller and smaller and smaller. So we're going to get this curve that's going downward. Next, it says, is it safe to cover the pool, or excuse me, it's safe to cover the pool after it reaches a depth of 1 foot or less. What is the minimum number of whole hours we should wait to cover the pool? Explain. So what I'm going to do is type this in my calculator and look at the table. So go to y equals, you're going to do 12 times 0.8 raised to, we're going to put it in as x because your calculator, it's something. Your calculator works in terms of x and y. So I don't know if you can see that. Now you can't. 12 times 0.8, raise it to the x, and then second graph to get your table. And we're looking for 1 foot or less. So if I look, I'm going to scroll down and let's do a table. So t is our hours. So that's really like your x. And then your y is really your depth, which is feet, or d of t. So if I look at like 11 hours, I see 1.0308. Now that's pretty close to being a foot, but technically it's still over. But if I go to 12 hours, I see 0.8246. So we know between an 11 and 12 hours that it got below a foot, or it hit a foot and then went below. But this said it wants whole hours. So we're going to say 12 hours is less than 1 foot. And then we use the table feature. We used table F, oh my god. I can spell words, maybe. Feature in our calculator. Okay. So let's do a couple more questions and then I'll let you be free. All right. For which of the following equations would an exponential quantity that begins at a level of 16, that sounds important, let's highlight that. So begins at 16 and decreases at 8% per hour. Okay, so when we're looking at these equations, since it's exponential, we know it's exponential because we have a percent. It's going to be 16 and then times something. Well, we've done nothing with negatives in there, so that's going down. And then we weren't adding anything, so I know it can't be choices 2 or 4. So because it is decreasing, there's a couple ways you can show it. You can do 100% minus 8%, and you're left with 92%, which if you turn into a decimal is 0.92. Or again, how you might see this in Khan Academy is they're going to do 1 minus 0.08 to get to that 0.92. Both of these are valid. They're just shown a little bit differently. So based on that, since it's decay, it has to be less than 1. So it's going to be choice number 1. All right. If $350, that sounds important. $350, oops, that's not even the highlighter. Sadler. Okay. Ugh. Let's try this again. $350 is placed in a savings account and earns 3.5% interest applied once a year. Then how much will the savings account be worth in 10 years? This is a great question. Great question. All right. So, all right. If it's interest and you're putting it in the bank, I hope you're earning money and the bank's not stealing your money. So we're going to do 100% plus 3.5%. We're going to get 103.5%, which we need to turn into a decimal. So we get 1.035 is how much it's growing by. So we're going to take that $350, multiply it by the 1.035, and that's for 1 year. But I want this to be for 10 years, so I've got to raise that exponent to the 10th power. Now, because it's money, we're allowed to round to the nearest hundredth. So let's see what we get. 350 times 1.035 raised to the 10th. We get $493.709, so about $493.71 would be the winner. So that is choice number 4. So exercise 5 is a really great example of a question that you could get on tonight's homework. So make sure you have that written down somewhere safe, because that is definitely a really good example. So again, your homework tonight is in Khan Academy. Homework in Khan Academy. There's 2 practices I assigned. Remember, they're each 4 questions, but I want you to try and get 75% or higher on each of them. If you need help, feel free to come join me in my office hours, and that'll also count as your check-in. So if you want to comment on here like, I'm here, I'm checking in, you're allowed to do that as well. So have a fabulous day, and hopefully I will see you on my office hours. Bye.